Hello everyone, welcome you all in today's session. So today we will continue same chapter permutations and combinations, and in today's class we will discuss all the questions related to exercise 6.4, right? So be ready with your pen and notebook. So this is question number 1, right? So here it is given NC8 is equal to NC2, to find NC2. So this exercise 6.4. So this is mainly related to combinations, right? So we will apply one formula here. We had already discussed the formula. So that was if NCP is equal to NCQ, then yes, then P will be equal to Q, or N will be equal to what? P plus Q, or P plus Q will be equal to N, right? So look at this one. NC8 is equal to NC2. So here P is 8 and Q is 2, right? So this first condition, 8 is not equal to 2, right? So we will go with this condition. It means what will be the value of N? N will be what? Here P is 8 and Q is 2. So N will be 8 plus 2, 10, right? So now we want to find NC2, means we will find 10C2, right? And I'm writing that formula again. We had already discussed this formula in class, NCR, right? So NCR will be what? N factorial divided by R factorial into N minus R whole factorial, right? So 10C2, so N is 10, so it will be what? 10 factorial divided by 2 factorial, and this will be 10 minus 2 whole factorial. And this will be what? 10 factorial, 10 minus 2 will be 8 factorial. So directly I'm writing 10 into 9 into 8 factorial. 2 factorial will be 2 into 1, and this will be 8 factorial. So this will be gone. We are left with what? 10 into 9 divided by 2, it will be 45. So what is NC2? It is equal to 45, right? So now question number 2. So here we have to find the value of N if 2NC3 is to NC3 is equal to 12 is to 1. So ratio is given, right? And I think everybody is aware about the formula. So for your convenience, I'm writing the formula NCR. NCR is what? N factorial divided by R factorial, N minus R whole factorial. So here in place of N, you're having 2N. So 2N factorial divided by R factorial. So that is 3, and this will be what? 2N minus 3 whole factorial, right? Is 2. So that will be what? Divided by, right? And I'm saving one step. So this will be what? In first step, it will be NC3. I'm writing this one. This will be N factorial divided by 3 factorial into N minus 3 factorial. So this will be what? If we write it in terms of multiplication, so we will take its what? We will take its reciprocal. So that will be this one, right? So here 3 factorial are gone. And now what we can do? 2n factorial. So this can be written as 2n into 2n minus 1 into 2n minus 2, 2n minus 3 factorial, right? Because in the denominator we are having 2n minus 3 factorial. And look at this one, into n minus 3 factorial is there. So what we can do? We can write this n factorial as n into n minus 1, n minus 2 into n minus 3 factorial. So n minus 3 factorial, this is gone. And other one, what we can do, this 2n minus 3, this one is gone. And we are left with what? 2n into 2n minus 1. And look at this one, guys. This will be, if we take 2 common. So we will have 4 into n. So 4n into 2n minus 1. And we are left with n minus 1. And this will be divided by what? N into n minus 1 divided by n minus 2. And on right hand side, it was 12 is to 1. So this will be 12 upon 1. Right? So this is n minus 1 is gone. And this will be gone. We are left with what? 4 and this is 3. Right? So we are left with 2n minus 1. And this will be what? 3 into n minus 2. So 3n and this will be 2n. So this will be n and this will be what? Minus 6. Right? And this will be what? Minus 6. So plus 6 minus 1. So n will be 5. Right? So let me check the answer. Yes, n is equal to 5. There is no calculation error. Right? So look at second part. You can see on left hand side, both are same. So what we can do, directly we can write till the point you can see here 4 into, yes, it was 4 into 2n minus 1 divided by n minus 2. Here we had cancelled out 4 and 12. So on right hand side, we are having only 11 upon 1. Right? So if we do the cross multiplication, so this will be what? 8n minus 4 and this will be equal to 11n minus 22. So this will be what? 3n, and if this will be like minus 4 plus 22, this will be 18, right? So n will be equal to 6. So in second case, your n will be 6. Yes, n equal to 6. So in this way, you can solve question number 2. So second part is same, just like we had solved part 1, right? So let us move to question number 3. So in question number 3, how many chords can be drawn using 21 points on a circle, right? So how many chords can be drawn through 21 points on a circle, right? So you know what is chord? If we are having a circle, so if we join any 2 points, so that will be a chord, right? So mainly to draw a chord, we need 2 points, right? So on the circumference, if we are having 2 points, so then we can draw a chord. So if we read this question carefully, so we are having 21 points. So if we join any 2 points, so then we can make a chord, right? So this question is simply what? Out of 21, you are choosing 2, right? So here selecting 2 out of 21 means that is question related to combination, right? And here order doesn't matter. You can take any 2 points. So 21 C2 means yes, NCR. So NCR will be 21 factorial divided by 2 factorial, and this will be 21 minus 2 factorial. So yes guys, 21 into 20 into, so this is 19 factorial. So we will write it as 19, and this will be 2 into 1 into 19 factorial. So this will be gone. We are left with what? 21 into 10. So this will be 210. So question number 3, yes, 210 is the correct answer. So let us move to question number 4. Question number 4 is, In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? I think this is very easy question, right? So we are having 5 boys and we want to select any 3. So this will be done in how many ways? 5C3 ways, right? And 4 girls are there and we want to select 3. So this will be done by 4C3 ways, right? And we are making a team, right? So this will be done by what? That we will use multiplication principle 5C3 into 4C3, right? So what is 5C3? Yes, guys, it will be 5 factorial divided by 3 factorial into 5 minus 3 factorial, and this will be what? 4 factorial divided by 3 factorial, 4 minus 3 factorial. So this will be what? 5 into 4 divided by 3 factorial is gone. So okay, no problem. I'm writing this one. 3 factorial into 2 factorial means 2 into 1 into 4 factorial. So 4 into 3 factorial, and this is 3 factorial. 1 factorial means 1 only. 3 factorial gone. 3 factorial is gone. This 2, we will get 2 here. So 5 2s are 10, 4s are 40. I'm getting 40. Let me check. Yes, 40 is the correct answer. So for question number 4, answer will be 40. So let us move to question number 5. Here we have to find the number of ways of selecting 9 balls from 6 red balls, 5 white balls, and 5 blue balls if each selection consists of 3 balls of each color, right? So first of all, we are having what? 6 red balls, 5 white balls, and 5 blue balls, right? And we want to select total 9 balls. But condition is each selection consists of 3 balls. So this is again very simple, just like previous question. So here from every like set of balls. So here for red we are having 6. So it will be what? 6C3 into 5C3 into again 5C3, right? So 6C3 will be what? 6 factorial divided by 3 factorial into 6 minus 3 factorial into, yes, 5 factorial divided by 3 factorial into 5 minus 3 factorial into 5 factorial divided by 3 factorial, 5 minus 3 factorial, right? So I think now you guys easily can solve this question. I am writing the direct answer. So this will be what? Total answer is 2000, right? So this will give you 20, this will give you 10, and this will be give you 10 again. So answer is 2000, right? So let us move to next question. Question number 6. In this question, what we have to find the number of 5 card combinations out of a deck of 52 cards if there is exactly one ace in each combination, right? So first of all, in 52 cards, how many ace cards are there? There will be 4, right? So without this ace, remaining cards will be how many? We are dividing it in 4 and 48, right? So we want to select how many? 5 card combinations, right? So there is exactly one ace card. So ace card can be selected from these 4 cards of 4C1 and what? Remaining 4 cards. So they will be selected from non-ace one, because exactly one ace card is required. So this will be what? 48C4, right? So 4C1 is 4 into 48 factorial divided by 4 factorial into 48 minus 4 factorial. So now I think easily you can solve this question. 44 into 48 factorial. Look at this one. This is 44. So we will open this till 47, 46, 45, then 44 factorial. And this will be 4 factorial. So this will be 4 into 3 into 2 into 1 into 44 factorial. So this will be gone. You can also simplify this one. 4, 4 gone. 3 2s are 6. 6 will be what? 8 6 are 42. So now simply you have to multiply 8 into 47, then 46 into 45, and together if you multiply these four numbers, so I'm writing the final answer. So what is the final answer? It is 7,78,320, right? So in this way you can solve question number 6. So your calculation must be strong, right? So here, if we talk about question number 6 or any question related to this exercise, so mainly we are using formula related to combination. And that was what? NCR. NCR means n factorial divided by r factorial into n minus r whole factorial. Right? And condition for r is same. That is, r cannot be more than n. So now moving to next question. Next question is, in how many ways can one select a cricket team of 11 from 17 players in which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers, right? So 4 bowlers are there, right? So no, we are looking for exactly 4 bowlers. So if you see this one, 11, total 11 players are there. So 4 must be bowlers and 7. So they will handle the different positions, right? So out of 4, they will be bowlers and 7 will be for other positions, right? So now look at, we are having total 17 players, right? In which 5 players can bowl, right? So mainly these 4 bowlers, so they will be selected from these 5, right? So here 17 is again divided into 2 categories, 5 players which can bowl and 12 therefore other positions. So what we are doing, out of 5 we are selecting 4, and here out of 12 we are selecting remaining 7 players. So 5C4 into 12C7. So directly I'm writing the answer. I think at this point, everybody knows how to find 5C4 into 12C7. Here, the main point is you have to understand 17 players are given, and we will divide these 17 players in 2 groups, right? So here, according to given condition, 5 players can do the bowling and 12 are for other positions. So 17 is divided into 5 and 12. So now we need total 11 players for cricket team, and out of 11, 4 must be bowler and 7 are for other positions. So mainly we are doing 4 out of 4, choosing from 5, right? So it will be 5C4 into 12C7. So what is the final answer, guys? It will be 3960. So in this way, you can solve question number 7. So let us move to question number 8. A bag contains 5 black and 6 red balls. So 5 black and 6 red. Determine the number of ways in which 2 black and 3 red balls can be selected. So this is, I think, very easy question. So out of 5, you are selecting 2, and out of 6, you are selecting 3. Right? So this will be, what is the final answer? This will be what? 5 into 4 divided by 2 into 1, and this will be what? 6 into 5 into 4, and this will be divided by 3 into 2 into 1. So if you simplify this one, what we will get? 5 2s are 10 and 5 4s are 20. So I think 200. Question number 8. Yes, 200 is the correct answer. So in this way, you can solve question number 8, which is very easy. So now question number 9. In how many ways can a student choose a program of 5 courses if 9 courses are available? Right? Till this point, suppose this is a question, then answer will be what? 9C5. Right? But it is given 2 specific courses are compulsory for every student, right? So it means out of 5, 2 are compulsory. Everybody has to choose, and these 3, remaining 3. So these are optional, right? So mainly 9 courses are there. Out of 9 courses, 2 are compulsory, right? 2 are compulsory. So remaining 7 will be there. And what we will do? We will choose any 3 out of 7. So in this way, if you understand the question, so easily you can solve every question in fraction of seconds. So this is what? Mainly we are finding 7C3. So 7C3 will be what? 7 into 6 into 5, and this will be what? 3 into 2 into 1. So what is the final answer? It will be 35. Yes, 35 is the correct answer. So question number 9, you will get, what is the final answer? It is 35, right? So now this is all about exercise 6.4, right? And now we have completed the whole chapter, permutations and combination. If you like this lesson, so you can share this with your friends, right? And in case of any query related to, whether it is related to 6.1, 6.2, 6.3, or from 6.4, you can share your queries through comments, right? And for more videos, you can subscribe Arena World Education, right? So thank you guys. Bye bye. Take care.